It's important to recognize misleading and deceptive graphs and identify exactly how they are misleading or deceptive. So some graphs simply contain errors, but others are technically correct but misleading or deceptive due to specific design elements. Some of the design elements that can make them misleading or deceptive are using a non-zero axis, having two graphs that have different scales, and using pictographs that use 2 or 3-dimensional figures inappropriately. A non-zero axis means that one or both of the axes begin at some value other than 0, so that the differences are exaggerated. Here's a bar graph that gives the percent of those who agreed with a court decision to have a feeding tube removed. And this is split up between political parties. So we have Democrats, Republicans, and Independents. And just looking at this graph, it looks like a much higher percentage of the Democrats agreed with the court's decision than Republicans or Independents. But if you actually look at the numbers, this is only 62% compared to 54% for both Republicans and Independents. And notice that the differences between those percentages are very much exaggerated because this vertical axis starts at 53 instead of starting at 0. This would be a case of a non-zero axis being used to exaggerate differences between values. If we redraw this graph using a zero axis, notice that this graph looks a lot different. The differences between the percentages are not nearly as exaggerated as they were in the graph on the left side. Using graphs with different scales is another way to give a misleading picture of two sets of data. Here we have two graphs, one for Extremo weight loss pills that shows the total weight loss in pounds of their customers. The other graph is for other weight loss products. Looking at the two graphs, it appears that much more weight was lost with Extremo weight loss pills than with other weight loss products. But if you actually look at the numbers on the scales of the graph, the one on the left, the vertical axis only goes up to 30, while the one on the right, the vertical axis goes up to 60. The one on the left is exaggerating the frequencies of customers who lost weight compared to the other graph. Also, if you notice, the horizontal scales are quite a bit different. The one on the left goes up by tens. The top value here is 50, but the one on the right goes up to 100. So the top weight loss for the Extremo weight loss pills was somewhere between 35 and 45 pounds, while the top weight loss for other weight loss products was somewhere between 90 and 110 pounds. That's a lot of difference. Now, another way that graphs can be misleading is if they use pictographs. And you actually see this quite a bit. Graphs, some of them use three-dimensional objects like money bags or stacks of coins or army tanks, people, etc. to show data. The drawings can create false impressions that distort the data, and one of the ways that this is done is by using either 2 or 3-dimensional figures instead of 1-dimensional figures to represent data. If you double each side of a square, the area doesn't just double, it increases by a factor of 4. If you double each side of a cube, the volume doesn't just double, it increases by a factor of 8. So especially using 3-dimensional pictures to represent 1-dimensional data really exaggerates the differences. Here's an example. The picture that we see here is misleading because it depicts 1-dimensional data with 3-dimensional boxes. The last box is actually 64 times as large as the first box, but the income figure is only 4 times as large. This is definitely exaggerating the difference between the income for those with no high school diploma, which is $18,734, and the income for those with an advanced degree, which is $74,602. But if you just look at the sizes of the boxes, this last box on the right looks huge compared to this first box on the left side. Now let's look at this with just a regular bar graph instead of using the pictograph. Obviously, the income for those with an advanced degree is still quite a bit more than for those with no high school diploma, but the differences are not so exaggerated. This is a much more fair way to represent this data.